Lesson 7. Add and subtract decimals. In this lesson, we'll talk about keywords, how to use a place value chart, some base 10 models, and estimating. So we absolutely love using cubes, especially when working with word problems that have multiple steps, as you'll see in 5th grade. We have a lot of that. So I've boxed the letter B because when we get to that part of cubes, so we circle our numbers, underline the question, we box our math action words, our keywords. These are the keywords you'll have to be looking out for if you are reading a word problem. These keywords may pop up at any time, and you'll be able to figure out if this question is an addition question or a subtraction question, or even sometimes both, especially for multi-step problems. Yes, I would actually suggest you knowing all of them. Just find a way to make them really familiar to you. Some of them kind of make sense, like plus, of course, is addition. Some is the answer to an addition problem. And the rest of them kind of make sense. Perimeter is a little funny, but it just means we're adding up all the sides of a particular figure. And for the subtraction ones, the biggest point of confusion for subtraction is this section here, because for some reason, when 5th graders read these words, they always think it's addition. If it has higher, longer, wider, faster, how much more, or how many more, it's actually a subtraction problem. The others are very self-explanatory. Minus is the operation we use. Difference is the answer to the subtraction problem. Less than, what remains, a remainder, decrease, take away, those all sound like something's being removed. But these here seem to give people a lot of trouble. So now that you know, you should be able to identify them if you see them in a word problem. Let's keep going. Okay, so our homework and our review problems often take us back to 4th grade, and they ask us about our whole numbers first before we apply any new knowledge to decimals. For our parents who are watching, this is what those words mean. I know it's a really big change for a lot of us. I especially didn't grow up with these words. So when you hear the words regrouping or decomposing, it's stealing and borrowing. It's what we were taught as stealing and borrowing from the next place value. So what it essentially means is when we remove that 1 so that it becomes 10 plus 3, and we do all of that. We regrouped that hundredths and made it into a bunch of tens. That's really what was happening. And so that's why students are using those vocabulary words instead, because it really makes them think about what they're saying and if it's really truly what's happening. Stealing and borrowing, of course, worked for us, so if you want to keep using those words, that's perfectly fine. They should know how to do it regardless. I'm going to do this problem right now, and I'm going to be using, hopefully, this vocabulary. I hope I don't resort back to my old ways. So let's start with this subtraction problem. It's 4 minus 1. So I can take away 1 from 4. That's something that I know I can do. I can prove that right now. I have 4 6. I can remove one of them. That is something that exists in the real world. So that's what I always check. 4 minus 1 is 3. Okay. So my next part, now I have to remove 9 from 3. 5th graders love to think they're removing 3 from 9. You cannot just switch the numbers around. If it's on the bottom, it stays there. So that means it's not possible. If I have 3, I can't take away 9. That doesn't make sense. I simply don't have it. If it doesn't exist, I can't do it. But what I'm going to do is I'm going to regroup from the next place value. I have a beautiful 100 sitting there, not doing anything. I know that if I break apart 100, I'm going to get 10 pieces of tens. I'm going to break it apart, and it's going to become 10. So now I have 10 plus 3, which is actually 13. Now I can take away 9. So let me prove that to you. I'm going to draw 13, 6, and take away 9, just to prove that it actually works. So here I have 13, and now I'm going to take away 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm left with 4. Because I regrouped the 1, it goes down by 1. I took it away. It's not there anymore. So now this number is just 0. And 0 minus 0 is 0. That one was easy enough. So what we did was we regrouped the 1 and turned it 100 into 10 tens. 100 became 10 tens, as you can see over here. My beautiful drawing. Next thing I'm going to do, I'm trying to remove 6 from 2. There's another problem. We can't take away 6 from something that doesn't exist. So we're going to have to regroup or decompose one of our 10,000s. We're going to go right next door to the 5. Hey, number 5, do you mind sparing one of your numbers? Of course. So the 5 is going to give away 10, and it's going to go down to a 4. So we decompose that 10,000 into 10 separate pieces, and now we'll have enough. So now we have 10 plus 2, which is 12. I'm going to do that here. 1. I'm going to add 10 to this bunch of 6 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total, I should have 12. I have 5, 5, and 2. Now I can remove 6. This makes sense. So I'm going to remove all of this. This is 5. Let's remove that. And one more. And I'm left with 1, 2, 3, 4, 5, 6. I'm left with 6. 4 minus 3. I can take 3 away from 4. That is something I can do. That's going to be 1. So let me check. Where should my comma go? 1, 2, 3, comma. That's where the comma goes. My difference, because it's a subtraction problem, is 16,043. Okay, so that is how we subtract properly for whole numbers. And guess what? Decimals are going to use the exact same rules. So if you knew the rules for whole numbers, you're ready to do the decimals. Let's move on to the next part of the problem. Ooh, what did we do? This problem is making sure we understand exactly what all that regrouping and decomposing and stealing and borrowing was all about. So let's look back. Did we decompose our 3 tens? Did I cross 3 out ever? I don't think I did. Let's check. I didn't cross out 3. I crossed out the 1 and a 5. So those were the 2 numbers that were decomposed. Let's look out for those. I did not cross out a 3. But I did cross out 100. That's something I really did do. I remember that. I did not cross out 2,000. But I did cross out 5 and turn it into 4 and gave 10 away. So I'm going to circle C and D as the correct answers. That's actually what I did in my problem. Let's move on. Okay. Let's do the same thing for addition. Well, this problem's already started for us. For the parents out there who are watching the video, regrouping, again, is just moving one number to the place value. That's all it means. We might say composing as well. You'll hear a child say compose. So that's what we used to call carry the 1. So if you're still using that language, it's fine. They should know how to do it either way. So 3 plus 3 is 6. 4 plus 8 is 12. I see the 2 there, but where did the 1 go? Oh, it was regrouped. There's not enough space for all of those 10s. There was 12 10s that came out of that problem, and there wasn't enough space. So only 2 of them could stay, and 10 of them moved over to the hundreds, because 10 is 100. 10 times 10 is 100. So now we have 7 hundredths in total. Let's keep going. 7 plus 6 is 13. The 3 can stay. There's not enough space for the 1. So that's going to be 10,000 moved over to the 10,000s place. Now we have 1 plus 2 plus 3. That should be 6. And finally, 6 plus 2 is 8. I'm going to check where my comma goes. 1, 2, 3, comma. And the answer is 863,726. We regrouped the 12 from 4 plus 8, see the 2, and the 1 got separated. And we also regrouped 13 from 7 plus 6 because it was just too big. There's not enough space for the 3 and the 1 to live in that place value. Let's keep that in mind. Okay. So for problem 3, we're supposed to look back at problem 3 and estimate the sum. That means we're going to be using some rounding. And then we're going to find the real sum. Maybe we already did. And we're going to ask ourselves, is it reasonable? Reasonable just means, is your estimate and your real answer close? Are they close? Do they sound like the same number? Are they pretty close to each other in a number line? That's all that means. So let's look at problem 3. Is this problem 3? I hope it is. So let's look at that. Let's estimate, even though we already did the problem. I'm going to round to the nearest 100,000. So this is my place value, and I have 2 choices. It can either stay at 6, as if you remember, or it can increase to a 700,000. I'm going to look next door, and I see a 2 there. That means it's going to stay at 6. Remember, 4 or less, let it rest. So it's going to be 600,000, my bad. 600,000. Let's do the same thing for the 236,000 down here. So this is my place. It can either stay at 2 or become a 3. Let's look next door. I see a 3. 4 or less, let it rest. So it's going to be 2,000. 200,000. Why do I keep saying that? Okay, so a quick addition. I know that all those zeros are going to end up being 0. So 0, 0, 0. Oh, we start at the back. 0, 0. And then 6 plus 2 is 8. So our estimate is, this is the estimate. Oh goodness, bad handwriting. Estimate is 800,000. Our real answer was 863,726. Is that close? I would say so. They even start with the same number, and they have the same amount of digits. This is pretty close. So that, our estimate, would go right on this line here. We would put our real answer here. And yes, our answer was very reasonable. It was very close to our estimate. So that means you probably added correctly. Now, it's time for us to look at the examples for decimals. So remember, whole numbers and decimals share the same patterns and sequences. So whatever you knew about whole numbers, might be able to apply. Some things don't work out as well, but a lot of things still work, including addition. So let's read the example. Alana walks 3 and 45 miles before lunch and 5 and 18 miles after lunch. How many miles does she walk in all? Oh, I heard a math action word. So we always do our cubes when we have a whole number. Not a whole number, a word problem. Cube starts with C. So we're going to circle our numbers. U, underline the question so we know exactly what we're answering. B, box math action words. Did you find any math action words? In all. In all is the math action word for addition. That looks like a multiplication sign. Let me make that really clear. This is an addition problem. Just like that. Eliminate. So we've done this, this, this. We're going to ignore everything else in the problem, and now we can solve. So this is how you use the place value chart. This place value chart is so nice for keeping numbers in line. So when we're adding, we see that 500 plus 800 becomes 1300. And we know that that is not going to work out. It's just not going to work. 1300, we're going to have to split those digits up. 3 gets to stay in the hundreds place, but that 1 has to go next door to the tenth, because 10 hundredths is the same thing as 1/10. That's why they sound like that. And then finally, 3 plus 5 is a nice clean 8. Oops, my goodness. 6, 4 plus 1 is 6. So let's carry the 1 up there. Let's regroup our 1. So in this example, they're showing you that 3 1s plus 5 1s is 8 1s. That's very true. That's not something that's going to change. 4 tenths plus 1 tenth is 5 tenths. 5 hundredths plus 8 hundredths is 13. We talked about that. So in total, because that 13 hundredths cannot stay that way, the 3 stays behind and the 1 goes next door. Instead of having 5 tenths, it goes up to 6 tenths. And so the total, or the sum, is 8 and 63 hundredths. Here's a subtraction of decimals. Again, we have a wonderful place value chart. Last year, Jeff ran the 40-yard dash in 5 and 8/10 seconds. This year, he ran it in 5 and 48/100 seconds. How much faster did he run this year than last year? That's a good question. So we have our cube for our word problem. Let's circle our numbers. Let's make sure they're important numbers. Last year, Jeff ran the 40-yard dash. Do we care that it was a 40-yard dash? It could be 100, 1,000. We actually don't care. In 5 and 8/10 seconds. That is important. This year, he ran it in 5 and 48/100 seconds. That is also important. So we got our circle, our numbers. Next, underline the question. How much faster? Well, let's make that better. How much faster did he run this year than last year? So we are talking about time. Our answer should be in the form of time, seconds. B, box math action words. Do you see a math action word? Let me go check really quickly. And this is something you can do whenever you're working, is pull out your math action words. I see an word. It said how much faster, and there it is. So it must be subtraction that we're doing. How much faster? That's a math action phrase or word. So we're going to say that we figured it out. This is subtraction. This is a subtraction problem. Eliminate everything else, and let's solve. So we're going to be regrouping, definitely. Let's take a look. Last year was 5 ones, 8 tenths, and 0 hundredths. Remember, 5 and 8 tenths is the same thing as 5 and 80 hundredths. Same thing. So let's subtract this year's time. Well, I have an 8 here and no hundredths. That's impossible. I cannot take 8 away from something that's not there. So I'm going to have to regroup one of my tenths. I'm going to take a tenth away, and it will become 7. And when we take that tenth and move it over and break it down, it becomes 10 hundredths. Now I have enough hundredths to take away. 8 minus 10 is 2. 7 minus 4 is 3. And 5 minus 5 is 0. So this year, remember we're talking about the seconds faster. The difference is 32 hundredths of a second faster than last year. The biggest mistake a 5th grader will make is trying to flip the numbers over or find a way to make it work like addition. Subtraction is different for a reason. It just works differently. You need to make sure that whatever you're subtracting is something that makes sense in the real world. If there's nothing there, you're going to have to decompose to bring something there, and then you're ready to subtract. Look at the example problem. We already did that. Jeff's brother Rob ran the 40-yard dash in 4 and 95 seconds. Oh, he must be super fast. Complete these steps. How much faster, there it is again, did Rob run than Jeff? I just want to make sure that I did everything right. Oh, let's move that a B. We circled. We kind of knew Jeff's time already from the previous problem. Underline the problem. How much faster did Rob run than Jeff? So again, we're looking for our answer should be in the form of time. Our math action word is faster, or how much faster, the whole phrase. Eliminate all that other stuff, and now we can solve. So, like before, we have our place value set up, and we can see that we need to subtract 5 from 8, take a 9 from a 4. Well, that's weird. How are we going to take 9 away from 4? I don't know. And 4 away from 5. That's something we can do. So let's start at the back like we always do. We always start off with our smallest place value when we're subtracting. 8 minus 5, I should say. 8 minus 5. Let's see. Let's see. 5, why is it like this? 5 ones minus 4 ones. Okay. Well, so we already figured out that this is going to be an issue. That 9 cannot take away from 4. So what we're going to do is decompose that 5, and you can already see it's going to become 4. And bring it over. Now it's going to be 10 plus 4. Well, that's 14. It's the same thing as saying 14 tenths. Okay? And that says 8 hundredths. It's still going to be 8. There's nothing special going on there. So, 4 minus 4, 4 ones, minus 4 is 0. 14 tenths minus 9 tenths is going to be 5 tenths. 8 hundredths minus 5 hundredths is going to be 3 hundredths. So the total difference is going to be 5 tenths and 3 hundredths. So Rob ran 53 hundredths of a second faster than Jeff. Make sure that's true. Yep. That should be okay. Alright. So when you're decomposing, you can also just think about that next number. It's going to just add 10. So that 4 just becomes 14. Here's another way to think about it. Marty cuts 2 5/100 ounces of cheese from a 4 6/10 ounce block of cheddar cheese. How many ounces of cheddar cheese are left in the block? Well, you can subtract using base 10 models. As you can see, they used X's to represent subtraction, like they were taking away. So they took 2 X's, so they removed 2 wholes, and they X'd them out. And they also removed 5/100. 1, 2, 3, 4, 5 are gone. So let's figure out what that last bit is. So we have 2 little holes left over. And what is left over here? Well, I see a bunch of tens and some hundredths. So 1, 2, 3, 4, 5 hundredths. Oh no, 5 tenths. And 1, 2, 3, 4, 5 hundredths. The answer is, well, the difference is 2 and 55 hundredths. And just for the sake of making sure we do cubes every single time, I'm going to make sure I do it before I move on. I circled my numbers. Underline, let's underline the question. How many ounces of cheddar cheese are left in the block? Box the math action word. Left is a subtraction math action word. I can tell myself that. It is subtraction. And E and F, which I've done. We did all parts of cubes. In Lesson 7, we learned how to add and subtract decimals. We explained some keywords, looked at the place value chart, we looked quickly at a base 10 model, and we even talked about estimating.